So on today, we will continue on layer 2, another important protocol that you should know, which is STP, or we call it as a spanning tree protocol. We are looking on what is spanning tree protocol, and then why we need a spanning tree protocol, STP, and also what actually the working principle. So how you're going to select the root bridge, how you're going to select the designated root port, and how actually you're going to calculate the recovery times, and also on the hands-on how you actually going to configure the STP on layer 2 networks. Okay, basically on Ethernet switching network, or normally we call it as a layer 2 local area network, some of the redundancy link you need to implement to ensure the network availability and also the network reliability. That means in case of any links that is broken, so at least we still have a backup link, okay, to transfer or transmitting the packet. But because of this redundancy, it always will going to produce the loops in a layer 2 local area network, which the loops, if you're not going to detect, it will going to lead into a broadcast storm and also the unstable MAC address wrapping. So that's why on this topic, we will going to learn spanning tree or the STP protocol to how actually we're going to handle the layer 2 loops and also to avoid the broadcast storm there. So basically, when you're going to enable the STP, okay, spanning tree protocol, it basically will change the STP BDPU to discover the loops on the network and also to block certain port to be a alternate or to be a backup port. So later on, we will going to see how actually we're going to select a port, which port it will going to block as an alternate or as a backup port in order to avoid the loops and the broadcast storm happening in a layer 2 local area network. And at the same time, we will going to see how actually the spanning tree protocol, which is going to solve and improve the performance of the STP protocol. So what we going to learn, what you are going to learn on this topic, basically you are going to see how actually, just now we mentioned the layer 2 local area network loops happening on the enterprise switching or the Ethernet switching network. And also we were going to see the basic components, concept and working principle of the STP. Then we were going to look in on how actually the RSTP is introduced to improve and enhance the performance of the STP and what is the differentiate among them. And how actually, if let's say now you already know the theory, how actually you're going to apply and configure the STP to enable it into the layer 2 and to stop and eliminate the layer 2 loops. Okay, the contents, the first one we were going to overview the STP, then we were going to look in on the working principle of the STP. We do learn the configurations, then we see the RSTP and what is the difference RSTP with the STP and also the STP advancement there. In enterprise networks, the local area network will be increased and more switch actually you are used to implement the interconnections between the hosts. So basically, most of the times your host will be connected to the access switch and your access switch will be connected to multiple access switch. You will connect it to the aggregated switch before you move to the layer 3 network. Okay, so when you going to connect your access switch to be the upstream aggregated switch. So if the uplink switch, example the aggregated switch, the link is null, so it will result your downstreams. Okay, your access switch they connected to your host, they cannot going to access the services and it will be connected for the network. And most of the times, we will going to delete this scenario to be a single point of failure. Okay, single point of failure. That means we are depending only a one link, okay, to ensures the network reliability. So if the only single link is down, okay, or broken, okay, so that means the other host or other access switch they connected to this aggregator switch, they cannot go into access the services and ensures the network availability there. So that's why when in a practicals, when we're going to design a local area network, we will going to include some of the redundancy design to ensure there is no single point of failure. Okay, so in layer 2, how actually the redundancy will be implemented. So for example here, now basically we will going to put the redundant or duplicated the aggregated switch. So that's in case, okay, the only single this aggregated switch, the link from this access to this aggregated switch A is down, we still can go through a aggregated switch B to access and to connect to the network. So by using a redundancy design, so actually it will going to improve the network reliability. But the issue is the layer 2, if we going to build the redundancy, so it will going to cause the layer 2 loops happen, which will going to resulting some of the communications quality. It might be slow down the network, and also it might be going to interrupt the communications services. Okay, so let's try to look into more detail how actually the layer 2 loops it will be happen whenever we have a redundancy links in a layer 2. Okay, so the layer 2 loops, okay, most of the times is a redundancy link. It's not necessarily caused by the network, but it will also caused by the human error. For example, this one, the network engineer or administrator, they're trying to do the incorrect connections of the cables between the device. So it will going to result the layer 2 loops happens on this part of the network. Okay, because you have a multiple link redundancy on here. And also, it will be causing also by the network engineer. Those are doing the redundancy on the link, but they did not go into enable the link aggregations, okay, to byte the connections between these two links as a logical link, aggregated link, Eth Trunk link. So it will also going to cause the layer 2 loops. Okay, so how, just now we mentioned we're going to see, right, it can be caused by the human when we put in the multiple link. So how actually the layer 2 links it will be happen. So most of the time it will be causing by the switch when they're going to receive what we call as a bump frame. The bump frame B, okay, it stands for the broadcast frame. Okay, U is stand for the unknown unicast frame. So what happens when the switch they receive an unknown unicast frame? It will going to broadcast. Okay, it will going to broadcast. For example, when the switch 3 they receive a unknown unicast frame because they did not who is a receiver. So what happened? They will going to broadcast to all, okay, the hosts under the same network, and also for the multicast frame. So all of these three frames, we categorize them under the bump frame. So whenever the switch they receive it, it will go into broadcast to all the network, to the devices they reside within the same network. So what happened? Okay, we're going to see on here. If let's say the switch 3, they receive the bump frame, it will go into broadcast. Then when the switch 2, they receive the bump frames, what happened? It also don't know who is the receiver. So what happened? The switch 2, it will go into broadcast also. Okay, to the switch 1 and also to the switch 3. So when the switch 3 receive again the broadcast frame, what happened? The switch 3 will go into broadcast again to the switch 2 and also the switch 1. Okay, the switch 2 and switch 1 will receive again, they unknown, they will going to broadcast again. So this will resulting the loops, okay, within the layer 2 become a larger and larger because they keep floating and they keep broadcasting the unknown frame. So it will going to closing what we call as a broadcast storm. So how the network engineers they know, okay, broadcast storm happen under the same network? Most of the time it can be detected whenever you see your MAC address is flapping. Okay, you see your MAC address. Normally, as we know, when you as a switch, how you going to generate your MAC address table? You are based on the source of the MAC address of the frames that you receive. So for example, if let's say now you are the switch 1, okay, you are receiving the frames, okay, from this source address, okay, 788A. Okay, you receive from the interface G001. So you are going to learn the source MAC address, right? So you are going to generate your MAC address tables. So this MAC address 788A, okay, is from this interface 001. Then when you're going to receive from the switch 2, they receive from the bump frame. So what happens? The switch 2, it also unknown who is the receiver. So the switch 2 will going to broadcast also. So the frames, when the switch 1 will receive, they also will going to receive. Okay, now the switch 002 is going to carry the 788A frame. So that means your MAC address, it will keep flapping. So most of the times when you are the network engineers, you notice that your MAC address is keep flipping. So that means if you are causing, that means they have a broadcast storm under your layer 2 lens. Okay, so how actually we're going to prevent the loops? As just now I said, we will have a STP, spanning tree protocol, used to prevent the loops to be happen under the switching network. It's used to prevent it's not it cannot go in whenever the loops is already happen. Layer 2 loops is already happen. It cannot go into stop after even you enable the STP. Okay, you should enable it before the loops is happen. So that's why we say STP is prevent, not going to stop lah. Okay, to prevent the loops, to eliminate the loops on the switching network. So if the loop is happen, what you can do, you just need the only way is unplug the cable lah. So normally we have to prevent it and enable the STP before the broadcast storm happen in your network. So how the STP work? Basically, they will going to pick, okay, one port under your redundancy link to be your alternate or the block port. Okay, the port will be blocked. So that's the whenever you have a loop scan. So whenever they forward to here, it will not go into bounce back again and broadcast to others also. So that's why it will going to stop under your block port here. So that's why we say under the STP, even we have a redundancy, then we certain port we will going to block it in order to avoid the loops or broadcast storm happening under your layer 2. Okay, so how the STP can dynamically respond to the network topology change and adjust to be a block port. As you're going to see, if let's say on this switch, we enable to run the STP protocol, and the STP protocols, they will going to exchange the STP BDPU to monitor the network topology. So normally, okay, later we were going to see the calculations of the STP to determine which of the port will be blocked. But now we're just going to see the theory, the principle working of the STP. So for example, under the switch 3, okay, this port is blocked, okay, to prevent the loops. So when the link between your switch 1 and switch 3, okay, is down, so what will be happen? So this just now under here, can this port is blocked. So it will be unblocked and enter the forwarding state automatically if you go into enable. Okay, as long as they detect the normal. By normal, you will going to forward through here because this port is blocked, right? So what happened if here is down? So this block port, it will going to take the actions and enter to a forwarding state to enable so that your data will going to forward from this way. Okay, this is the advantages of the STP, not only going to prevent, but they actually can be dynamically respond to the network topology change and also adjust their block POC. Okay, so on here, we just want to highlight again what is the differences between the layer 2 and layer 3 loops. So just now what we mentioned is under the layer 2 local area network or the Ethernet switching network, you have to apply the STP, okay, specific or RSTP or MSTP protocol to stop the loops. But in a layer 2, that means your routing, okay, your routing protocol. So basically, how you're going to prevent a loop, you have to base on your TTL. When they move from one router, one hop to another hop, your TTL will be -1. So this one will going to prevent, okay, the infinite or the loops of the packet forwarding under the layer 3 loops. Okay, but under the layer 2, you have to apply the STP and the variants of the STP loops. That means STP, then RSTP or the MSTP. Okay. So in how actually whenever we move to the campus network or the enterprise network, where you going to apply your STP? So basically, we will going to apply it under the layer 2 network, means between your access switch and also your aggregated switch. Okay, we don't seldom we going to apply under the we're not going to apply under the layer 3 that involve the routing lah. So it should be under the layer 2 networks, okay, to implement the link backups and also to animate the loops. Okay, so we deflash again. What is a STP? Basically, it's going to prevent the loops happening under the local area network, layer 2 network. So device running the STP will exchange the informations. Basically, they will later we were going to see they will exchange two kinds of those BDPU. Okay, we want another to discover the loops on the networks and how actually they're going to block the certain port. And whenever the topology is changed, how actually they're going to dynamically to respond to that topology change, and they're going to automatically switch the block port, okay, to the forwarding state. And also, whenever the glow of the scale of the local area network, STP have becomes the importance protocol for the local area network because you need to do the implement the redundancy. Okay, next we were going to see what is the basic concept and also the working mechanism of the STP. Okay, the first concepts that you need to know is a BID. BID, we call it as a bridge ID, bridge identity. So the bridge identity total is have been 64 bits. So it will be including for a 16-bit for the bridge priority and 48 bits of the MAC address. So this one questions have been asking in the past year questions, how many bits of the BID? So remember the BID is consisting of the bridge priority and the MAC address. Bridge priority, you have a 16-bit, and also the MAC address, you have the 48-bit. Okay, so the bridge priority, basically you can go into configure the number starting from the 0 to 65536, and the default, okay, default bridge priority is a 32768. So this one you also need to remember. So when you want to change the bridge priority, it can be changed, but it must be from the multiply for 4096. That means you can change it to be a 0. You can put it as a 4096. You can put it as a at 102. Okay, you can go into multiple at 192. Okay, then you go, as long as they are the multiple of the 4096. Okay, so you cannot going to put 2155. No, Why? Because it's not a multiple of the 4096. So this one is how you're going to set the bridge ID. So most of the times the bridge ID, why it is important? Because the bridge ID will going used to determine who will serve as a root bridge under the networks lah. Okay, under that switch network. Okay, so the root bridge, normally we will going to look in on the smallest bridge ID. So remember, bridge ID, we have two parts. So for example, for this network, okay, we have a switch 1, switch 2, and switch 3. So who will be a root bridge? We will going to look in on their bridge ID. The first part is a bridge priority. So on this example, switch 1, switch 2, switch 3, the bridge ID is the same. So we cannot decide who will be the root bridge. We need to look in on the second part based on their MAC address. Okay, so the MAC address, they are different from the last digit, right? Last four, 102A, 102B, and 102C. So 102A, 2B, 2C, who is the smallest? So that means this one is the smallest, right? So that means the smallest bridge ID, you will going to select it as a root bridge. Okay. So the next one, we were going to understand what is the responsible for the root bridge. Just now we say how we're going to select the root bridge. We base on the bridge ID, BID. Okay, what is a bridge ID? Is based on your bridge priority and also the MAC address. So the same example, so that means our switch 1 will select it to be a root bridge. So with the smallest MAC address. Okay, so basically the root bridge, they will going to function as a root of the three networks. So we call it as a logical. Okay, it's not necessarily the physical centers. It will be the logical. Then the root bridge, basically they will going to change dynamically with the network topology. Okay, so after the network coverage is complete, the root bridge normally they will generate and sense the configurations. Okay, they will going to sense the configurations BDPU to other device at the specified intervals. Later we will going to learn also the intervals under the STP, the default one. So what happened? The other switch, they will going to process and forward the configurations BDPU to notify their downstream. So for example, under this network topology, switch 1 is selected to be a root bridge. So what happened? It will going to do the calculations. So it will going to periodically, we're going to sense the configurations BDPU to the downstream. Okay, so the downstream it will going to forwards. So who will going to forward this BDPU configurations? Later we will going to see lah. Okay. Another concept of the STP is the course. So each of the port under the switch, they have a course in your STP. Okay, by default, we say the higher port bandwidth, it will going to indicate a smaller port cost. So for example, 520,000 here. So that means 500 cost is smaller than a 20,000. That means 500 here, they have a higher, okay, bandwidth compared to a cost here. Okay, so the default cost of the port actually how we going to decide. It will based on the rate, working mode, and also the STP calculations methods by a switch lah. Okay, basically the cost for each of the port it will use to calculate the root part cost. Okay, so this root part cost will help us to do later on some of the STP calculation in order to decide who will be the root port there. Okay, so for example, if I want from the switch 1, I want to reach a switch 3. So how actually I going to calculate the port cost? I will going to end up from here to the switch 2, switch 2 to switch 3. So switch 1 to switch 2, my cost is 500. Switch 2 to switch 3, so my cost is a 20,000. So total up we have a 23,500 is a total root part cost that I need to forward my data from the switch 1 to a switch 3. So you have to remember by default, the Huawei is using a standard of the IEEE at 0.1T to calculate the part cost. So what is the advantages when we're going to using a 1T compared to others standards that have been using by the other vendors switch? Okay, we refer to this standard here. Just now we mentioned by default, Huawei switches are based on the standard IEEE X02.1T. Okay, and also of course they have some of the very old legacy switch. They are based on this root part cost. Okay, what is a difference when I using the X02.1D and also the X02.1T? You can go into looking on here. Whenever reaching, okay, the 10 gets to here, the root part cost, if you are using a IEEE 2.1D, there is no differences. Whenever you have a port rate 100 compared to a 40, okay, all their root part cost, it only can be is 1. So actually, if you go into forwards your packet, of course, you are more prefer using a high bandwidth compared to others than your port rate. So, but if you are using a X02.1D, there is no differences. So that's why currently all the switches of the Huawei, they are based on the IEEE X0.1T. So you can see the differences. Okay, when you are going to forwarding the data bit, okay, under a 100 to a 10, okay, even for the future enhancements there. Okay, so the cost have a default value and is associated with the port rate. When the device use a different algorithm, the same port rate will corresponding to a different cost value. Okay, so this one is how the advantages lah. If you using IEEE X02.1T, you can see the differences of the port rate whenever we are going to using a different bandwidth. Okay, the next one, we will going to see how actually we're going to calculate the root part cost. Just now I already mentioned how you're going to calculate the root part cost. Okay, for the switch one, you want to the cost that you send the data from the switch 3. So how actually you're going to calculate your 500 and also your 2000. So you add on. So this one is the root part cost. Okay, so basically why we need to calculate the root part cost, because basically you have different routes how actually you're going to forward your data. Okay, so the root part cost, it will go into to decide lah, okay, which of the path that actually is an optimized path for you, or to select to forward your data, or to select the shortest path to forward your data. So if you're looking on this scenario, so on here you have a 20. Switch 3, from switch 1 go to a switch 3, so your root part cost, it will be a 40,000 compared to if the switch part you forward to a switch 2 and switch 2 you go for a switch 3, so your root part cost you only have a 20,500. So which one you are going to select as your optimum path? So of course you are going to pick for this one. This one, your forward data, you are going to forward from the switch 1 to switch 2 to reach the switch 3. Okay, why? Because based on the root part cost. So basically under the STP, your root part cost for your root bridge, always it will be a 0. Okay, next one we're looking on the port ID. Okay, port ID. So basically port ID will help to select, okay, do the elections who will be the designated port. Okay, the port ID are basically you have a 0 until 240. Okay, and it should be a multiple of a 16, and the default value is a 128. So don't confuse your port ID with the bridge ID. Okay, bridge ID is a 32768 for the default value, but for the port ID is for you to select your designated port. Bridge ID is used to select the root bridge. Okay, don't confuse on it. So basically, port ID consists of the leftmost 4 bits port priority and the rightmost 12 bits. So total it also have a 16 bits. So basically, you will going to select who will be your designated port. Okay, another one is a BDPU. Okay, the bridge, okay, protocol data unit. So under the STP, we have two types of the BDPU. Okay, so one we call it as a configurations BDPU, another we call it as a topology change BDPU. Okay, so basically your configurations BPDU, it will consist of your bridge ID, path course, and also your port ID. So the STP will select the root bridge by transmitting the configurations BDPU between the switch and determine the role status of each switch port. Okay, so how actually we going to decide, okay, who will be the root bridge, who will be a LAN root bridge? We are based on the configurations BDPU. Okay, once the network is stable, so normally the BDPU only configurations BDPU will only send by the root bridge only. Okay, but before we going to select who will be a root bridge, so actually each of the switch under the same network, they were going to send their configurations BDPU. From there, we were going to detect who the bridge ID, okay, is the smallest, then it will going to select as a root bridge. So after we select the root bridge, the network topology is stable. So that means, example from here, only the switch 1 is a root bridge, so only the root bridge will going to proactively send the configurations BDPU to others. So once the others, example, the switch 2, they receive the configurations BDPU, so it will going to forward to a downstream switch 3. Okay, so TNC. Okay, topology change notifications BDPU basically is sent by a downstream. Okay, switch 3 to be the upstream to notify there is a topology change. Okay, example, if let's say they detect this one is a block pocket, so they detect they did not receive, okay, the configurations BDPU from the upstream. So they know something is happened already. So they were going to trigger the TNC BDPU, go up to the upstream there. Okay, so what inside the configurations BDPU? Basically, here is all the informations. Okay, you have to know the types of the BDPU. If 0x00 is stand for the configurations BDPU, and 0xx0 is stand for a TCN, topology change notifications BDPU. Okay, so the flags, so this one is the flag. Later on, we were going to see that what happened if we enable the STP, the topology change. So how actually they going to sense the topology change with the TCA and also the TC. Okay, there will be a bridge ID, your root path cost. Okay, so another important on here, the maximum edge. By default, the maximum edge, it will be a 20 second. So this one later we were going to see how in which part we were going to calculate it. So if the bridge does not receive any BDPU of a period of times and the lifetimes of the network bridge reach the maximum, the network bridge consider that link is connected is 40 already. So that means we consider dia mati sudah. So you only wait for the maximum 20 seconds, and then the downstream they were going to trigger the topology change. Okay, so the hello time intervals by default is 2 seconds. Okay, for the root bridge to sense the configurations BDPU. Okay, forward delay from each of the steps. Example, from the distancing to a learning, okay, is a 15 seconds. Okay, so STP operations. So basically, when we're going to enable the STP, we want to calculate the root-free topology on the switching network. So during the topology calculations, we will going to compare the configurations BDPU. So under the configurations BDPU already mentions, they have a root identifier, root path cost, bridge ID, and also the PID. Okay, so how actually we want to select, okay, the root or everything, we will base on this. First one, we will going to select the smallest. Always remember layer 2, we looking on the smallest. Bridge ID will become the root bridge. Okay, smaller root path cost, it will becomes a root port. And then the smallest bridge ID of the network bridge, it will become a designated port. And also the larger port with a larger bridge ID, they will become a block port. And then the smaller PID. That means on here, the first one, we will going to, based on the bridge ID, we select our root bridge. The second one, for each of the non-root bridge, we will going to select who is the root port. So after we select a root port, we will going to determine the designated port for each of the networks. So how we going to design decides the designated port? We base on the bridge ID lah, and then also to decide who will be your block port. So larger one will become a block port. Okay, so based on these 4 rules, that means we will going to define 3 types of the port. One is a designated port. Okay, one is a root port. Another one is a alternate port, which we are block them alternate port. Okay, so we will going to see on how actually we going to calculate. But before we going to calculate, we're going to see how actually when the switch we enable the STP. So how each of the switch they going to exchange their configurations BDPU. Okay, when the switch we enable the STP, they start. So they will consider themselves as a root bridge, and then at the same time they will going to send the configurations BDPU to each other. So for example, now the switch 1, okay, it will consider himself as a root bridge. So it will going to sense the configurations BDPU by telling what is the bridge ID. Okay, then the root path cost is a 0. Then the bridge ID, so this one is the bridge ID because they assumes they are the on root bridge kan. So the PID, so they will going to forward. So when the switch B, they going to receive, okay, switch B, it will going to compare, okay, the root bridge. Okay, when the switch B, they basically actually the switch B will also send the BDPU configurations to the switch A. So the switch A when received from the switch 2, because the root bridge is larger than the switch A, so the switch A will going to decide himself as a root bridge. So the same when the switch 2 they receive the switch A configurations BDPU, the switch 2 will compare, and then because this one B is larger than the A, so the smaller one will become a root bridge. So that's why on here the switch 2 will going to put, okay, the bridge ID of the BID of the root bridge is the A1, and then the root path cost they will going to end up their cost 20,000, and then the BID of the root bridge they will going to put themselves and the port ID. Okay, then it will going to forward to the switch 3. So same as the switch 3, they will compare the C with the A. So across the A is the smallest. So the root bridge will remain is a switch 1. Okay, so then the switch 3 will going to forward to downstream by calculate the root path cost. Okay, this is how initials when the switch start, everyone they will consider themselves as a root bridge, and also to sense the configurations to each other, compare. to decide who is a root bridge. Okay, we're looking on here how we going to calculate the whole to determine who will be a root bridge, and then how we going to decide the root port, okay, designated port, and also the block port on here. So the first thing, how we going to design the root bridge? Okay, this three type is a port that we're going to calculate. So before we going to calculate the port rule, okay, port rule row here. So we will going port row, that means we will know who is your root port, who is your designated port, and who is your alternate, or we call it as a block port. Okay. Before that, we need to decide who will be your root bridge. So the root bridge, how you going to decide? Remember just now in the initial slide, I mentioned is based on your bridge ID. The smallest the bridge ID will become a root bridge. So we're looking on this topology, they have a 3 switch 1, 2, and 3. So how we going to looking? First, we will going to looking on the root priority, bridge BID, bridge priority. So priority 4096, 4096, 4096, all will be the same. Then we will going to compare the second part of the bridge ID, which is a MAC address. So on here, across the 2A is the smallest compared to a 2B and 2C. So that means switch 1, it will become a root bridge under this network. Okay, so after that, it will going to trigger the configurations. Okay, it will going to trigger the configurations BDPU. Okay, so they each others they will going to compare the BID. So at the end, the comparison is the 102A will be the smallest and elected to be the root bridge. Okay, so remember under the Huawei switch, the root bridge you can be preempt. Okay, that means you can be reset it, because it will be happen when a switch with a smaller BID, when they're going to join the networks, that network will going to perform the STP calculations again to select the root bridge lah. So that means that's why the root bridge most of the times we say it can be preempted. Okay, so after we decide the root bridge, the next one we will going to decide the port rule. Okay, so we will going to calculate who will be your root port. So how you going to calculate the root port? Basically, it will based on the shortest distance. That means we need to consider based on their root path cost. But if their root path cost is the same, then we will compare to their bridge ID. If the bridge ID is the same, then we will compare their port ID. Okay, port ID. So for example, under this network, again, switch 1 with the smallest bridge ID will become a root bridge. So normally after we recite the root bridge, so remember the root bridge will not have a root port. So basically we will immediately to put here is a designated port. Okay, so now we will going to compare the root path cost. Okay, so basically the root path cost opposite the switch 1, it will become a root port. Because when you go into example from here, by default, if let's say you put 500, so here also is a 500. Of course, when I reaching on here, the root path cost it will be increased. So that's why you were going to put the roots on here, root port. Okay, so you just remember, once you recite a root bridge, immediately here you will become a designated port, DP, designated port. And then opposite your designated port, it will become a root port. Okay, so the next one. Okay, on here, so how you were going to select it to be your block port. Basically, you will base on the bridge ID as just now I mentioned. So on here, So which of the port it will go into block? That means switch 3, they have a larger bridge ID. So that means this port you will go into block and become the alternate port. Okay, so next we will going to see how actually we try some exercise in order to help us more understanding on how actually we going to select the root bridge and then to determine the root port and also the designated port and also the alternate port. Okay, we're looking on this example. You have a switch 1, switch 2 and switch 3. Okay, switch 1, switch 2 and switch 3. Always the first one you're going to decide who will become your root bridge. Okay, how are we going to decide the root bridge? We base on the smallest bridge ID. Smallest bridge ID. So what is a bridge ID? Again, it will consist of your bridge priority and also your MAC address. So we're looking on the bridge priority. So on these cases, all the bridge priority is a 4096. So we cannot use it to determine our root bridge. So we will going to compare their MAC address. So MAC address, all the last 4C1F, AABC is the same. So we're looking on the last 4 digits. So we have a 001, 002, 003. So who is the smallest value? So it's a 4001. So that means the switch 1, it will become a root bridge. Okay, once you decide the root bridge, immediately we know that here will become your designated port. Why? Because your root bridge will not have a root port. Okay, you need to know who will become your root port. So the root port basically it will going to have a smaller root port cost. Okay, so you're looking on here, who will have a smallest root port cost? Of course, it will be under your switch 3 G001 and switch 2 G001. So that means here will become your root port. Okay, so after that, you will going to decide again who will become your designated port and which port will become a block port. Because under here, you root designated port, root port. So on here, you are going to decide who will become an alternate port to be a block, who will become a designated port. So how we going to select? We will going to looking for the alternate port with a larger bridge ID will become an alternate port. So that means which one have a larger bridge ID 002 and 002? 3 and 2. So that means switch 3 is a larger value. That means this port will become a alternate block port. Alternate port, and here will become a designated port. Okay, so you already do all the things. Okay, how you going to select the root bridge based on the smallest bridge ID. After you select the root bridge, you are going to look in on the port rules. So 3 types of the rules that you need to determine under the STP. The first one is your designated port, root port, and the another one is your alternate port. Okay. So next we're going to see on this example, we have a 4 switch. Switch 1, switch 2, switch 3 and switch 4. So again the same, you need to find out who will be your root bridge first. Then you're going to determine the root port under the STP. We have 3 types. Who will be your designated port, root port, and also the alternate port to be a block port. Okay, so let's discuss the answer. So the first one, who will become a root bridge? Again, we're looking on the bridge priority. So all four switch are the same priority. So we're looking on the smallest MAC address ID. So that means the 001 is the smallest MAC address ID compared to others, right? So that means your switch 1 will become a root bridge. Okay, after you determine the root bridge, immediately here will become your designated port. Okay, because the root bridge will not have a root port. Okay, so how are you going to determine your root port? It will be based on the shortest path. So that means shortest root path root cost. So here will become your root. Right. So again, once you go into looking on here, now you need to decide. Okay, this one will be your which of the port you will become a block port on here. Okay, so you have a G002 and G001. So which of the port will become your alternate port? Of course, we will go into looking on a, because now this here, these two on here, that means here will become a designated port, So which one will become the alternate port? If our bridge ID is the same, we will looking on the port ID. So G002 and G001, of course, the larger is a G002. So the G002 here will become the alternate port. Okay? So this is how actually we're going to determine on it. So let's try another example. They have only two switch. So who will become an alternate port? So the first thing, the same, you need to determine the root bridge and also the root port. So again, who will become the switch 2 and 1? Who will become the root bridge? Of course, it's a switch 1 because 001 is smaller than the 002. So here will become the root bridge. Okay, after you decide your root bridge, resonator port. Okay, so now the question is which one will become an alternate port? So because G001 and 2 is belong to the same bridge ID, so we will looking on the port. So that means this G002 will become the alternate port and here will become a root port. Okay, after we already understand the elections of the STP, that means how we actually going to decide the root bridge and then how actually we going to determine the port rules. Okay, under the STP elections. So the next step, we want to understand the port state. Okay, what will be happens and how actually they going to changing their state from the blocking to a forwarding state. So basically under the STP, we have a 5 port. First is a disable. So disable, they cannot go into sense and receive the BTPU. This one also is one of the famous past year questions. They were asking what actually the rules and what actually the operations they can be performed by each of the port under each port state. Okay, if we mention the blocking, that means they cannot sense the BDPU, but they can distance. Blocking can distance to the BDPU, just they cannot sense, they cannot receive, and they cannot learn the MAC address. Okay, when we move to the distancing, that means they can send and receive the BDPU, but cannot sense or receive the service data, flame, or learn the MAC address. Okay, cannot learn. Okay, same like a blocking. Okay, blocking is cannot sense the BDPU. Distancing, you can send and receive the BDPU, just you cannot send or receive the service data flame or learn the MAC address. So most of the time under the distancing, you are under a root port or the designated port. Okay, if we say the learning, That means actually you are learn the MAC address and you are going to distance to and or send or receive the service data lah, because you need to learn your MAC address. And forwarding, basically you can go into do the sending and receive the service data from and process the BDPU. So only the root port or designated port can enter a forwarding state. So if you under the alternate port, you want to move to a forwarding state to become a root port. Okay, example, another one is a keyword also you need to remember, BD RA. Alternate port is going to backup the root port. Okay, backup port is going to backup the designated port, because later under the RSTP you are going to see another backup port there. Okay, just remember alternate port is used to backup the root port. So example, under the alternate port is under the blocking state. So in order to reach up the forwarding, so they should going to transfer to a distancing and then transfer again, move forwards to a distancing and then baru boleh do the forwarding. Okay, in order to understanding on here, you can go into looking. Okay, normally the on here, when the port is initiated or activated, it will automatically enter the blocking state. Okay, once the port is selected as a root port or designated port, and automatically enter the distancing state. Okay, so for you to move for the distancing to learning to forwarding, actually here you need a 50 second and here you need a 15 seconds. This one we call it as a forward delay. Okay, so for the forward delay time expired, the port is still under the root port or designated port. The port is no longer the root port or designated port under the for, so they will going to go back lah. Okay, the port is disable or link fail, so it will going to disable to move to a disable or null port under the file. Okay, so this one also is one of the exam questions. They were asking whether under which state actually you can move directly to be a disable or down. So that means each of the port state, blocking, distancing, learning, and forwarding, it can be moved back to a disable or the null state. Okay. Same for the forwarding, learning, and distancing, they can move back to a blocking as long as they are no longer a root or the designated port. Okay, so now we want to see what happened, okay, if the root bridge failure. So this one also is a famous STP questions. They were asking you what happened if, let's say, the root bridge is failed, okay, is failure. There, so it normally need to take a 50 seconds to recover. Okay, so we were going to see why we say it's a 50 second. So when a root bridge is failed on a stable STP network, a non-root bridge, they periodically will going to receive the configurations BDPU from the root bridge kan, dia akan send the configurations BDPU. So if the root bridge is failed, there are malfunctions already, so the downstream of your switch 2, they actually will not going to stop receiving the BDPU. Okay, so your downstream, when they did not receive the BDPU from the root bridge, they know that the root bridge is mati already. But how they know it's mati already or whatever, they will base on the maximum edge time. Okay, so if the downstream, for example, the switch 3, okay, they did not going to receive the BDPU from the upstream switch 2 because the switch 2 did not receive from the switch 1 kan as a root bridge. So what happened? It will going to keep wait until a 20-second maximum time edge. Okay, so after the maximum time edge, what happened? It will go into records and then it will become the invalid. So in this time, your non-root bridge actually they were going to trigger to sense the configurations BDPU to each other to elect the new bridge. So for the port stage, what happened? under the switch A is under the alternate port. So it will going to move alternate, it will going to move to the distancing. Okay, for the blocking, move to the distancing. For the distancing, if move to the learning and move to the forwarding. So basically, it will going to need another 30 seconds. Okay, 15 seconds to move for the blocking to distancing, and then distancing to learning another 15 seconds. So it will go to take 15 times 20 maximum time H. Waiting for the configurations BPU. So total, it will need 15 seconds to recover for the root bridge failure. Okay. So if the physical link, okay, if a physical link failure, that means whenever the two switch they are connected to a two link, and one is active and another is a standby link. Okay, one is active and one is a standby under your root bridge. So basically, you need 13 seconds to be recovered because you no need to wait for a 20 second maximum time H. You just go into distancing and then you change from the alternate port. You just need to change to be your distancing, learning, and forwarding. So that's why you only need 30 seconds to recover. Okay, you just remember as long as it's a direct link connected to the switch, you need 30 seconds. As long as the port or the link is not directly connected to the root bridge. So example like just now the case scan is on here. You need to connect to the switch to indirect can. So that means actually you need 15 seconds to be recovered back. So we're going to look in on this example. Unphysical link. Okay, your link, okay, you are on the A here. Your alternate port is located on here. So it's not direct connected to your root bridge. So you have another connections from the switch 2 to switch 1. So you need to waiting the maximum time H from the upstream. So that's why you have to wait another 20 seconds to reach out the maximum times to recover. Okay. So this is normally the exam they were asking on you whether there is a physical, unphysical, okay, direct link, indirect link. So how actually the maximum maximum times the time they will use to recover the indirect link and direct link failure. So indirect link, you need a 15 seconds. So what we mean by the indirect link, that means you are not connected directly to your switch 1. Okay, you still have a upstream switch there. So that's why you need to waiting another 20 seconds for the maximum time H. Okay, on a switch network, a switch normally we are forwarding the data based on the MAC address table. So for example, under the switch tree on here, in order to reach out the host B, we are going to tell you have to go through a G00 through and forwarding to a host B to a switch 1 and then to a switch 3. Okay, so on here because there is a topology change on the switch tree. Okay, from this link is fault. Okay, it's broken, cannot forward anymore, go through this link. But in a MAC address under the switch 2, they still did not aware because the aging time of the MAC address tables is 300 seconds. So actually they did not aware there is a link fail under here, switch 1 to switch 2. They did not aware again. So because their aging time is 300 seconds, so they still will going to forward their data, go through a G003 and reach out. At the end, the data package cannot going to reach under here because the link is broken already. So actually they cannot go into cover. So how actually they going to solve this kinds of the problem? So you need to trigger the topology change notifications BDPU to notify the other switch that this link is now already. So you have to using the Ethernet port to forward link your data go through here. No more go through switch 1. You have to send directly from switch 2 to switch 3 by go through a G002. But how actually they're going to trigger this issue, we will going to see on the next slide. Okay, so when the topology change, okay, the root bridge, they were going to send the topology change BDPU to notify the other switch of the topology change. So basically, the root bridge, they were going to generate the TC, okay, to generate the TC to instruct the other switch to flush, okay, to etch their existing MAC address entry. So this is what the process will be happen. So after the switch 3 on here, they detect there is a topology change because this link from the switch 1 G002 here is down already. Kan? So what happened? The switch 3, they will go into generate the TCN. Okay, topology change notifications, TCN BDPU to a switch 2. So after the switch 2, they're receiving the topology change BDPU, it will go into sense the TCA, okay, acknowledge to flag that actually I received already your TCN BDPU, okay, to change it, the flag change it to be a 1 to a switch 3. Then at the same time, they will go into instruct the switch 3 to stop to sending the TCN BDPU. Okay, otherwise the switch 3 will keep sending the TCN BDPU. So once the switch 2 will receive, they will going to set the flag and send back the TCA. Okay, I received already your TCN BDPU. So after that, your switch 2 will go into forward this TCN BDPU to a root bridge, because on this case we assume the switch 1 is your root bridge. So what happened? The root bridge, it will going to send the TC, okay, in the configurations to send the TC bits in the flag configurations to be a 1 and sends to the configurations BDPU to instruct all the downstream switch 2, switch 1, or to change the aging type of their MAC address from a 300 TC from a 300 bukan 30, 300 seconds to the forward delay value. That means change from the 300 forward delay, it will be a 15 seconds. So that means the incorrect MAC address on the switch 2 entry, it will be flustered, automatically delete after a 15 second at the most, and then they will start to learn against the source MAC address, and then it will go into forward the package based on the correct one. So this is what they actually going to handle, okay, to flush the old MAC address tables corresponding to the forward delay 15 seconds. Otherwise, it will be your data will be lost because it still will going to go through a broken link. Okay, so how they actually going to handle these issues? They will going to go through the TCN, TC, and TCA and TC notifications to flush or delete the old entry of your MAC address after a 50 second follow the forward delay times instead of the default 300 seconds. Okay, the next one, we already understand the basic STP configuration, so we were going to see how actually you going to enable the STP under the Ethernet switching. So to enable it actually by default, all the switch under the Huawei is using the NSTP, but NSTP is under the HCIP syllabus, not under the HCIA Datacom syllabus. So we were going to learn it for those the network engineering program. They were going to learn it under the HCIP syllabus. So how you going to enable the STP mode? You just need to type the STP mode and then you type the STP. But default is an STP. Okay, so how you going to determine your root bridge? Okay, you are going to configure as a primary. So if you're going to set STP root primary, that means you are going to set the priority of the switch as a 0. One is set as a 0, it cannot be changed. So for example, just now we got previous slide, I mentioned some switch when they going to joining this network, they might have a smaller bridge ID. So if they joining with a smaller bridge ID, it will result the trigger a new STP calculations, and then they take over the root bridge kan. So to prevent that things to be happen, so you will go into set it to fix kan dia, okay, STP root priority, so that whenever there is a new switch with a lower or smaller bridge ID to join the STP network, it will not going to result a STP calculations again and take over the root bridge. And also you can go into set the backup, the secondary root bridge by using the STP root secondary. So basically, if you're going to set the secondary, you will going to set as a 4096 and it cannot be changed. Okay, primary is a 0, secondary is a 4096. Okay, you also can go into set the priority for the STP, but by default is a 32768. Okay, and also you can determine the path course. By default, we are using is a .1LT to calculate the path course. And then you can also determine the course of the path course by using the STP course. So the configurations, you also can set the port priority by entering to a port level. So you type the STP priority, you set it by default is a 128. Okay, then you're going to enable your STP after your configurations. So you can try to build out this topology. Okay, then you're trying to enable the switch 1 as a root bridge. So you're going to set the priority as a 0. That means it will become a root bridge. So the second switch, you make it as a secondary root bridge by using the STP priority 4096, or you can using the STP secondary. Okay, and then the third switch is a normal. Okay, so after you going to enable the STP, you can go into check display STP brief. You should go into see the roots row there. So you will go into under your switch tree. So your block 1, it will become a alternate port, and the state it will be discarded. Okay, to check whether your configuration is correctly or not. Okay, the next step we were going to see the improvement made under the RSTP because of the performance of the STP lah. So they introduce again the RSTP to enhance the performance of the STP. So the STP, we know we have a 5 state. Okay, this 5 state moving from the distancing to a learning to a forwarding, it require a 15-second forward delay time to move from the learning to distancing to forwarding another 15 seconds. So actually it consider a slow convergence, and it will going to have the impact of the service quality there. So that's why this is one of the reasons why they introduced the RSTP and also the NSTP to improve the performance. And also another issues under the STP, they did not differentiate the port rule according to their state. Because under the learning state, under the distancing state, we can go into see it will be under the root port and also the designated port. Okay, the state are the same for all the user because none of these ports are following a service traffic. And in terms of the port use and configurations, the essential difference between the port in the port rows but not the port state. Okay, both port and root and designated port can be in the distancing and forwarding state, so the port rules cannot be differentiated according to their states. So they have some of the confusing, okay, between the port rules and also their state. And also the STP does not determine the topology change until their time expired. So it will going to further delay the network convergence, and STP require a root bridge to sense the configurations BDPU after the network topology change become stable, and other device will process and spread the configurations BDPU through the entire network. So this one will also delay the convergence. Okay, so next one, how we going to we will going to see the RSTP going to improve the performance of the STP. So RSTP is defined under the IEEE 802.1 chapter. So it will be compatible with the STP. That means you have some devices, some device they're using the STP. So actually it can be back forwarded to be a RSTP. Okay, that means they are compatible. But of course, the modes they are running, it will be based on the STP. Okay, for those of the switches, you are using a STP together with the RSTP. So of course, it can be compatible with the STP. But if you only have the STP devices, so that means they only can run the STP feature only lah. So basically, it have been introduced under 2001 defines the under the standard of the IEEE. So the improvement of the STP and implement the fast network topology coverage. Okay, so basically the principle is quite the same, just under the RSTP, they are based on the proposal agreement. Okay, PA mechanism. You are going to see proposal agreement mechanism to recover the network's connectivities there. And another big differences is they trying to remove the three-port state, okay, by defining another new port rules and they trying to distinguish it. So they have alternate ports to obtain the alternate path from the designated bridge to a root bridge. So that means they have another port. We call it as a edge port and also the backup ports there. Okay, and then they also have a reduce the state. Okay, from the 5-state to a 3-state. Okay, so we were going to see each of these differences there. Okay, RSTP process the configurations BDPU differently from the STP. When the topology becomes stable, the mode of sending the configurations BDPU is optimized. So they're using a shorter time-out intervals of the BDPU. Then they optimize the methods of processing the inferior BDPU. The RSTP change the configurations BDPU formats and use the thread field to describe the port rules. Then the topology change processing RSTP is optimized to accelerate the response to the topology change. So remember how they're going to achieve? They're using a proposal agreement mechanism. Okay, so the rule under the RSTP, they have another new, we call it as a edge port and also the backup port. So just now, before when we learning the STP, I mentioned they have a R, A, and B, D. This one always will be asking under the exam, so make sure you don't confuse. So alternate port is used to backup the root port. Backup port is used to backup the designated port. That's why here is a short form for you to remember RA. Okay, root port is backup by the designated port. BD, backup port is used to backup the designated port. And also we have another one is a edge port. Okay, so you're looking on here, you have a designated port, your opposite will be a root port. Okay, your designated port, and then here will be your alternate port. Okay, so you under the RSTP, they have an extra port, we call it as a backup port to backup your designated port. Okay, And also, they introduce another new port. We call it as a edge port, which is directly connected to a host. Okay, but you remember this edge port, they did not receive or process any configurations BDPU. They did not participate under the RSTP calculations, and they can directly transit from the disable to a forwarding. This is how we say the RSTP, they can be do a fast convergence compared to the RSTP because they have a one edge port. We can be transit directly from the disable to forwarding without wasting a 30 seconds. Okay, to move to the alternate to be a distancing to be a learning to be a forwarding port state lah. Okay, so this will going to increase the speed on how they cover just the network. So edge port in general, normally it will go into direct connect to the user terminal. So it will be transitions from the disable state to a forwarding state directly. Okay. So basically the edge port, it will become a common STP port lah once it's received the configurations BDPU. So the spanning tree will be decovered, which will going to result the network flapping there. Okay, so how now we already understand the differences of the port rules between the STP and RSTP. Under the RSTP, just now we mentioned we have the extra backup port for the designated port, and also they introduce the edge port. We can be directly moved to the disable to a forwarding port there. Okay, now we're looking on the port state of the RSTP. The port state of the RSTP, we only have a 3 state. Compared to the STP, we have a 5 state. So this one, they also will be one of the famous questions they asking under the HCIA Datacom exam. So RSTP, they have a forwarding, learning, and discarding. They don't have a blocking and disable. Okay, under the forwarding, that means you are going to forward the user traffic, you are going to learn the MAC address. Okay, so the port, it will be a root port or designated port. Under the learning, you will not going to forward the user traffic, but you learn the MAC address. Under the discarding, you did not forward the user traffic and you did not learn the MAC address. So normally this one they will asking under the questions, under which stats and what actually they can do. So make sure you are clear lah. Okay, so the discarding, always it will be under the edge port, backup port, and also the disable ports there lah. Okay. So another one, of course, under the all the Ethernet switching. Okay, most of the times we were going to using the RSTP, and by default is an STP lah, but that one is under the HCIP syllabus. So STP and RSTP, both they actually have a defect because all the VLAN they actually on a LAN they are sharing a one STP. Okay, so how actually you going to enable, and you need some of those mechanisms, okay, especially when you have the VLAN routing, inter-VLAN loop balancing. Okay, they cannot be performed and they will block the link, cannot transmit any data, which may lead to the VLAN packet transitions failure. Because when we're talking about the VLANs, you have just learned it. Okay, we have a layer 2 VLAN and also the layer 3 VLAN, inter-VLAN routing. Okay, so if you enable the STP, so that means we cannot do the inter-VLAN there. So how actually we going to solve these issues? Okay, under the Huawei, they introduced a one new spanning tree. They call it as a VLAN-based spanning tree. Okay, so they will going to construct a spanning tree in each VLAN so that the traffic from a different VLAN, it can be loop balancing along a different spanning tree. So the benefits of the VLAN-based spanning tree, or we call it as a VBST, basically they will emulating the roots they will implement the link multiplexing and also the loop balancing. So they will going to improve the efficiency there, and also they will reduce the configurations and also the maintenance cost lah. So when or if there is a great number of the VLAN exit on a network, so spanning tree calculations for each of the VPN, actually they will consume a lot of the switch processor resources also. Okay, so that's why Huawei introduced a VLAN-based spanning tree to solve these kinds of the issues lah. Okay, another one we also have as what I mentioned, we have the MSTP, Multiple Spanning Tree Protocol, in 2002, introduced and released by a standards of the IEEE under the standard 801S. Just recall back, if we are talking about the VLAN is a queue, okay, T is a STP, W is a RSTP, and S is a MSTP standards. So same things like a RSTP, MSTP actually is compatible with the STP and RSTP, and it can be rapidly coverage the traffic and provide a multiple path to loop balancing the VLAN. Okay, so basically what the MSTP they were going to do, they will divide your switching network into a multiple regions. That's why we call it as a multiple spanning tree. Okay, which each of them, they have a multiple spanning tree. They are independent of each other. So inside the MSTP, each of the spanning tree, we call it as an instance. Okay, multiple spanning tree instance. So each of the instance actually is a spanning tree that corresponding to a set of the VLAN. Okay, so binding a multiple VLAN to a single MSTI, it will going to reduce the problem that we mentioned just now, to reduce the communication cost and also the resources usage, especially for the processing power of the switch. And the topology of each MSTI, they will going to calculate independent, so the traffic can be loop balancing under each of the instance. And multiple VLAN can, within the same topology, they can match to a single MSTI. So the following state of the VLAN of the interface is determined by the interface state in the MSTI. Okay, so under the Huawei, okay, when we have a multiple switch, okay, you want to do, so basically you have to handle a different configurations there lah. Okay, so under the Huawei, they introduced the iStat, or they call it as a intelligence stat. Okay, it enables the multiple iStat capable switch to functions as a logical device. So before the iStat system is set up, so each time each of the switch, they actually are the independent entity. They have their own IP address and MAC address. So basically, you as a network engineer, you need to manage the switch separately, which is time consuming and very troublesome. So after you going to introduce the iStat, okay, is set up. So basically the switch in the iStat system, they will going to form the logical entity, and they can be managed and maintained using a single IP address. So the iStat system basically how they going to form the logical entity. Basically you have a single IP address. So basically it will also going to improve forwarding performance lah, by using the Eth Trunks and to increase the network reliability, and also they simplify the network management. So this is the advantages on if we are further using the intelligence stat, okay, to manage our campus aggregated switch there to ensure the network reliability, to prevent the layer 2 loops, and also to improve the link bandwidth utilizations. Okay, and also under the Huawei, they also going to introduce the smart link here for a dual uplink networking. So if you're looking on this figure, so basically your switch tree, okay, is connecting to your firewall 1 and also the firewall 2 with a 2 uplinks here. Okay, so in this way, the switch tree, they will have a 2 uplinks to the uplink device. So basically, you can going to apply the smart link, okay, on the switch tree to configure. So in a normal situations, the link on the port 2, they will going to serve as a as a backup. Here, dot dot dot, that means it's a backup link. So if the port 1 link is filled, so that means they will going to automatically switch to a port 2 lah. So this one we're going to ensures the network reliability and also ensures the service continuity there lah. Okay, by using the smart link features offered by the Huawei. And the smart link is easy to configure lah. This one is just for your knowledge only lah. Okay, so before we end up our syllabus, again on this topic, we learn about the STP. We learn about why we need a STP. Of course, we want to prevent the loops and also the broadcast storm. And also how actually we're going to detect the broadcast storm. Basically, you are going to notice your MAC address table under the switch, it will keep flapping. So we learn about the working mechanism under the STP, how we're going to select the root bridge, okay, based on the smallest bridge ID, how we're going to determine the root port, okay, designated port, and also the alternate port under the STP. And also we will going to see the elections of the STP and also the port stat from the STP. They have a 5 port stat. And then we're going to see how actually the RSTP going to improve the problem of the STP by introduce another 2 different edge port. So that means two different port. One is a edge port, another is a designated port. And also how to reduce the 5 stack to be a 3 stack in order to increase the coverage of the STP. Okay, so now we're going to see and also the last few slides, we're going to talk about what is a RSTP, MSTP, and then what is the advantages of the iStat and also the smart links offered by the Huawei to enhance the management and to reduce the maintenance and the processing power of the switch lah. Okay, so now we're looking on this quiz. Which statements about the STP port stat is a false? The block port does not distance or sense the BDPU. STP port. The block port does not distance or sense. So this one is a false. Okay, they did not sense, but they actually distance to the BDPU so that they can go into changing their stat can. So the port in the learning stat learn the MAC address but does not forward the data. True. The ports in the distancing state keep distancing to the BDPU, distancing, betul. If block port does not receive the BDPU within a specific period, the port will automatically switch to the distancing port. Yes, this one that means they were going to switch from the block port to the distancing to the learning to be a forwarding. So the incorrect answer, the false one, will be the A. Hi, so on this topic, we will still remain under the layer 2 Ethernet switch on how actually we're going to aggregate a different ring, or what we call it at the Huawei, we call it as an Eth Trunk. Then we were going to look in further details on what is the intelligent stat, iStat, and also the CAS cluster link. Topic we more focus on the RSTP, STP, and also the MSTP, and how actually it going to improve the network reliability, okay, and to solve whenever we have a network redundancy, how actually we going to prevent the loops. So for these chapters, we are more focused on the Eth Trunk. okay, intelligence, ISTAT, and also the cluster switch system on how actually we're going to improve the network's bandwidth and also the reliability. So the objective, you are going to looking on what is a link aggregations and what is their functions, and we were going to looking on two types of the link aggregations. One we call it as a mode and manual mode, and one we call it as a LACP link aggregations control protocol mode. And we were going to look in also the ISTAT and also the CAS and what is their advantages and principle when we're working with the enterprise and campus network, and also to understand the common applications where we're going to apply the link aggregations and stacking technology there. Okay, so biologically, most of the times, not only the network, okay, we will go into, same like if you're going to learn the database, we also need to ensure, always need to ensure the reliability. So under the network, the reliability normally is refers how actually we're going to ensure the non-stop network services when a single point or multi-points of the failure in occur on a device or link. So how actually we going to ensure the network availability whenever one of the link or one or more of the link, okay, is failure, is broken under the network. So under the network reliability, when we're going to talking about it, it will cover under your card device and also the link. So for this one, you can go in to see once the network is rapidly develops and applications become more and more diversified, so they have a value and service widely deployed. So the network interruptions, it will going to cause the many network assumptions and also the huge of the economy loss, especially example if you are involved currently, example like a TikTok, okay, and also other social medias they not only focus on the social networking, but also they are actually provides the e-commerce services, okay. So that's why a network reliability becomes important. So on these chapters, we were going to see whenever you have a network, how actually we have a redundancy, and also at the same time we do some of the logical link aggregations on our physical link to increase the network bandwidth there. Okay, but at the same time, how actually we apply the ISTAT to do and reduce the maintenance cost and management procedure there. Okay, so just now we mentioned under the network reliability, okay, one of the level is we looking on the card reliability under the switch. So of course, under the switch, if you going to looking on their hardware design, basically they have a power module, fence module, then also they have their MPU, or what we call it as a main processing unit, and also they have a switch fabric unit, okay, and also the LPU, they call it as a link processing unit. So basically each of these, they will have their own functions that you can go into rate one by one. So how actually they going to enable the redundancies to ensure the failure of the card. So basically, failure of the single MPU, it will not, because they also have a redundancy backup on here. So it will not go into affect the normal operations of the control platform. Similarly, under the SFU, okay, so they have a backup also. So the active and deactive are active and standby. Okay, so that means the data plan, they can still forward the data if the active one is down. Okay, the same things for the LPU. So the interface on the LPU will not go into affected. Okay, so another level, it will be under the device reliability. So how actually we want to ensure whenever a switch, especially the aggregator switch under your campus or enterprise network is down, so basically you need to using another backup switch, okay, to ensure the device reliability whenever your aggregator or your core switch is down. So at this you have a backup one to continue forwards the data package. Okay, so under another one is what we more concerned on today is the link reliability. So basically, just now we mentioned for the device reliability is on your aggregator of the core switch, and the link reliability, that means if let's say this physical link is down, so you will have another backup link to ensure the link reliability. Basically, if let's say just now you learn the STP, so it will go into unblock by your STP and moving to a forwarding step lah. Okay, we will going to look in on the details on what is a link aggregation. So the first, we looking on the advantages of the link aggregations. Across, we have whenever you have a redundancy to ensure the network reliability. So you have a multiple link exit between the devices, but all the link, if you going to enable under the STP, so that means only the traffic will be forwarded by one link. So basically in this scenario, it will go into forwarding under the first link here, okay, by using the interface here. So the other link, you will going to block it. So basically in this case, the inter-device link bandwidth, they will remain unchanged lah. But actually when you're going to look in on here, actually you are wasting the bandwidth kan. But basically you actually can go into using this link to forward the data also. But if you're going to enable it, you have a redundancy of the link, it will going to dissolve a layer 2 loops, and also it will going to causing a broadcast storm and make a trace scrapping issues, as what we just now we learned under the previous topic. So how actually we going to enhance or to enable to avoid the wasting for your link bandwidth? We can apply the idea what we call it as a Ethernet link aggregations, or we call it as a Eth Trunk. So we will going to bundle a multiple physical link to be a one logical link. So because we bundle into the one, it will not go into causing a layer 2 loops. And also at the same time, it will going to increase your link bandwidth, and without you have to upgrade your hardware. So basically, you still have them under a separate physically, is a separate physically link, but in a logicals, you were going to bundle them under a one Eth Trunk link. Okay, so we were going to learn the basic concept of the Eth Trunk link. So basically, the Eth Trunk link, you were going to first, you were going to look in is a group, or we call it as a link aggregation group. So basically, each of the link aggregation group, they will have a one logical interface. We call it as a Eth Trunk interface. So under a link aggregation group, you have a member interface, or we call it as a member link. So physical interface, they constitute a Eth Trunk link are called a member interface, and the link corresponding to a member interface, we call it as a member link. So example on here, we call it as a member interface, and this one we call it link, member link. So at the same time, Eth Trunk link, we have an active interface and inactive interface, or active link and inactive link. So the active interface, example is symbol by X here. So basically it's an active link that participates. They will responsible to forwarding your data. And the link on here, we call them as an active link. For the interface or member interface, they will not participate in forwarding the data. We call it is a inactive interface, or we call it as an unselected interface. So the link, we call it is an inactive link. So under the LACP, okay, link aggregations, we have two type modes. One we call it as a manual mode, and other one we call it as a LACP mode. That means we're using a protocol, link aggregations control protocol mode. Okay, so where we going to determine who actually can join the member interface under your Eth Trunk LAGA group. So basically, we will ensure this parameter is must be have a same interface send duplex modes and also the VLAN configurations. Then we can do the Eth Trunk. So this one also is one of the famous questions under the HCIA Datacom. Okay, next one we were going to see a manual mode. Okay, under the manual modes, that means you will do the manual configurations to aggregate the link. Okay, so you will not going to using a protocol, LACP protocol, to negotiate under the two system lah. So most of the times when you're going to apply the LACP is whenever you find out either one of the ends of the LAG group, they did not actually support the LACP protocol. So you don't have the choices, then you have to apply the manual modes lah. Okay, in most of the case, all the link will serve as a active link to forward your data or to share your data. So if let's say either one of the link is null, so the LAG they will automatically share the traffic with the others three link here. Okay, remaining active link. Okay, so for you to ensure the Eth Trunk they work properly, so you have to ensure that the peer interface of all the member interface in the Eth Trunk they meet the following requirements lah. So first one, the peer interface must be designed on the same device, and also the interface are added to the same Eth Trunk. Okay, so if you looking on here, okay, you have a 4 interface under your switch 1, okay, and then they are added into the Eth Trunk, but you look in the peer one of the interface of the switch 3 on here, they are going to send to a switch 3 instead of the switch 3 kan, same like the other switch 2, switch 2, and here is a switch 3. So in these cases, so that means the sum of the traffic, it will be loop balanced to the switch 3, then it will going to causing some of the communication assumptions there lah. Okay, so also you have to remember whenever you enable the manual mode, so the device will not going to exchange the package and negotiate it, because every configuration is manually configured. Okay, in manual modes, the device can determine whether the peer interface is working properly only based on their physical layer status, whether they are up or down. Okay, because you don't have the protocol to control them, so you only can detect based on their physical layer status. Okay, if you want to simplify the configurations and also the management, most of the times we will apply is using a LACP protocol. Okay, so in a LACP mode, so the link aggregations use the LACP protocol. So that means they will exchange the link aggregations control protocol data unit, or we call it as a LACP DU, to ensure the peer interface and member interface belong to the same internet and are on the same devices. So normally under the LACP DU, what they going to have, they have a device priority, MAC address, interface priority, and also the interface number. So we're looking on here to understand the LACP priority. Okay, under the LACP mode, we have to ensure all the active, the number of the active or selected interface, it should be consistent. Okay, that means if here is 4, here also will be a 4, the number. Otherwise, the Eth Trunk, they cannot be set up. Okay, so if let's say your switch 1, you only have a 3, make sure your switch 2, you also have a 2. Okay, so in this case, also most of the times you need to ensure one of the end, either a switch 2 or switch 1, you are going to configure as a actors. Okay, then they will going to select their active interface. So how are they going to select the actors? It will based on the system priority. Okay, the smaller value again is under Eth Trunk, is under the link layer 2. So we will going to look in on the smaller value have a higher priority. By default, the priority of the LACP is a 3276 lah. Okay, so that means we will use the lower priority to be the ether. Okay, so what if the priority is the same? So we will base on the MAC address of the switch. So the smaller MAC address will indicate the higher priority. Okay, so after we going to select the priority, so we will going to determine who will be the actors. Okay, so both device will select the active interface based on the interface priority of the actors, and the smaller LSCP interface priority value will indicate the higher priority. So that means your LSCP will select the active interface based on the interface number. The smaller interface number, that means they have a higher priority to become the active interface. Okay, the maximum number of the active interface. What if the number of the member interface they exceeds the maximum number of the active interface? So the interface with the higher priority and the smaller interface number will be selected as the active interface. For example, on here, because you set your maximums, Eth Trunk interface is 2. But on here, you have 4 members. So how actually we going to select which interface will become the active member, maximum 2, okay? So we will base on the interface priority. That means smaller interface number and higher priority will be elected as a active member, okay? Next one, if the active link is filled, so the inactive with the higher priority, so again is based on the smaller interface number have a higher priority, will be elected to replace the faulty link. For example, if let's say now just now is a link 1 and link 2 become a active link, right? So now if let's say, the 2 have broken, is not functioning. So that means your 3 will be selected compared to 4. Why? Because the interface number have a smaller interface number have a higher interface priority will be selected to be the active link to replace the faulty link. Next, we will try the practice on how actually we going to do the elections for the active link. To determine, first you need to find out who will be your actors. So again, how we going to determine who will be actors? It will be depends on the MAC address ID, kan? So it will going to compare the MAC address 6064 and 6065. So which one is the smaller value? It will become the actors site. So that means it will go in under your switch 1. So that means the switch 1, it will go into determine it. And if let's say here they give the scenario, the maximum active interface, it will go into set to be a 2. So how you going to determine who will be the active? It based on your interface number. So on here across the X1 and X2 here, it will become the active. So these 3 and 4, it will become the inactive. So remember how we going to select the actors? It will based on the system priority. So how we going to check the system priority? You were going to see, but on this diagram, they did not give you the system priority. So that's why you have to checking on their MAC address. As just now I checked 6064 and 6065. Next, how we going to determine the active link? Just now we mentioned you only have to select a 2, okay? So we will going to look in on their interface priority. So the lowest the interface priority, it will become a active link. So here they also did not give us the interface priority, so you have to look in on the interface number. So that's why X1, A1 and 2, they will become the active interface, and 3 and 4, it will become the inactive interface. Okay, after you already determine your election, so the X1 will notify the peer end of the selected active and interface through a LACP packet. So LACP, they were going to use the flags under the LACP DU to identify the interface status. So if the three flags are set to be a 1, so the interface will become the active interface lah, synchronizations, collecting and distributing. If they are set as a 0, that means they are inactive. Okay, so after that, the switch tool, it will determine the local active interface also based on the elections result of the switch 1. So the corresponding 1 and 2, they will become the active link lah. So this is how actually the elections of the active link, they will going to complete under the 2N, switch 1 and also the switch 2. So on here on the loop balancing, also we have a 2 modes, but in a real world, we more recommend to use the per floor loop balancing compared to a per packet loop balancing. If per packets loop balancing, that means you have a multiple physical link between the device and the data, that means one package of the data, you are going to have a partitions, right? Package 1, 2, 3, 4, and each of them will going to forward to through a different link. So later on, you will have the problem to disassemble them. So it will result out of orders package. Okay, but if you're using a floor balancing, so that means all the frames of the same floor, they were going to transmit it under the same physical link. So this one, it will not going to closing out of orders package when you're going to disassemble the data. That's why we more recommend to using a per floor loop balancing compared to a per packet loop balancing there. Okay, so for the loop balancing, also you can go into determine based on whether you want to do is a IP address loop balancing or the MAC address balancing lah. So normally in the cases, if your IP address, okay, it will be changed frequently. So most of the times you are going to do the loop balancing based on the source IP address, destination's IP address, or source or destination's IP address. But in case, if your MAC address package are changed frequently, okay, and your IP address always is a fix, so that in the cases you were using a MAC address, either you are using is a source MAC address, destination's MAC address, or source and destination's MAC address to do a balancing lah. Okay, so if let's say the selected loop balancing mode is actually unsuitable for the actual service characteristic lah. So basically your traffic may not be unevenly loop balanced. So some member they have a high load and some member they have a totally did not send the data. Okay, in there. So that's why when we say you have to check the conditions lah. If the source and destination IP address is always changing, so you have to do the loop balancing based on the source and destinations, okay, of the IP address instead of using a MAC address. Okay, last one we're going to look in on the typical applications where you're going to apply the Eth Trunks lah. So basically, we want to ensure the bandwidth and reliability of the link between the switch. We will going to apply a multiple physical link. So you are going to Eth Trunk them. So in order to avoid the loops there lah. So at the same time, if you have a switch and server, you also can go into Eth Trunk them to increase the bandwidth and reliability of the server by binding a 2 or more physical network interface lah, NIC group. Okay. Then here also you can go into apply the Eth Trunk like just now we learned under the previous topic under the aggregated switch there. Okay, to enable the high reliable group free network, and also you can apply under the firewall, okay, to do the hot standby, okay, to Eth Trunk the link. Okay, how we going to do the configurations of the Eth Trunks? Basically, it's quite straightforward. You just going to the Huawei interface Eth Trunk, and also you are going to create your Eth Trunk ID. For example, here you're going to put the trunk 1. So after that, you are going to determine the mode is a LACP or the manual mode. Then you are going to that particular switch and the interface to bind to the Eth Trunk groups that you have created. Okay, then after that, you are going to add the Eth Trunk to your interface to your Eth Trunk. Okay, then you are going to enable the interface in a different thread to join the same Eth Trunk. Okay, so you are going to mix thread, link, enable. Because by default, just now we're going to looking at how actually the Eth Trunk you are going to select one of the criteria, it should be a same thread. So if you want to ensure they have a different thread, you have to enable the mixed thread link enable. Then here is how actually you're going to change the LACP priority. By default is a 32768. Okay, then how you're going to change the LACP priority on the the interface priority there. And here you how many maximum active link you can go into set it. Okay, so this one you have to ensure the local end and also another peer end. Your switch 1 and switch 2, it should be the same maximum number link. Jangan you configure one on the switch 1, you configure as a 2, another you configure as a 3. It should be the same. Okay, so basically maximum number of the active interface, it will going to depends on the switch model. If you are using a Huawei under the X series 67, okay, so normally it will have a 32 32 maximum. Okay, so you also will going to configure the minimum, okay, to ensure the minimum bandwidth. Okay, so this one you can select, and also can be different. Okay, minimum number, it can be different on the local and peer. Difference from the maximum, maximum it should be the same. But for the minimum, it should be it cannot be same. Okay, if the bandwidth is too small, the service that require the high link bandwidth may be abnormal. So at the case, you can go into disconnect your Eth Trunk interface to switch the service to another path. Okay, through the high reliability mechanism to ensure that the service can be run normally. Okay, this one is the example. You just going to draw a true switch on switch 1 and switch 2. Okay, this one you cannot draw. You just draw the ring under your ENST tooling, and then you try to do the configurations on this switch 1 and switch 2. Okay, this one is a manual mode. Okay, and here is a LACP mode. So you have to enter each of the switch to do the configurations. On here, you are going to set the LACP switch 1 as a actors. That's why you're going to reduce the priority. So that's by default is a 3276, right? So it will going to elect the switch 1 to be the actors. Okay, so this one is under the switch 2 You're going to do the same. So remember, when you do the Eth Trunk, you have to allow your trunk ports to allow past your VLAN. Okay, lastly, we were going to see some of the advanced features for offered by the Huawei technology. So again, we have an iStat, and now we were going to look at another one. We call it as a cluster switch system. So basically, the iStat, it will go into allow a multiple switch connected using a stacking cable from a logical switch to that participate in a data forwarding. Okay, you have a multiple stacking table, so it will be logically help you to manage. So for the clustering switch system, 2 CIS cable switch are bundled into a one logical. Okay, it's to ease the maintenance and the management. So a CCS now basically consists only two switches. Generally, it will be a modular switch to support the CAS and also the fixed switch to support the ISTAT. Okay, the advantages why we need a ISTAT and also the CAS. If you're looking on here, the CAS basically it only have a one logical switch, so it will going to simplify your operation and maintenance works lah, and facilitates the management. So if the physical device is faults, the other device can take over the forwarding and control. You no need going to physically or manually going to check it because you already stack them and clustering them together as a one logical switch, so they will automatically to switch and to prevent a single point of failure. So the same thing for the ISTAT lah. So you will going to Eth Trunk, okay, the link aggregations to implement the root-free physical. So all the link in the Eth Trunk are used and the usage will be a 100%. So if anything is down, so that means they will going to automatically help you to manage and recover it. So many to one virtualization switch can be virtualized into one logical switch that have a unified control plane. Okay, so you no need to go through every single physical switch to do and manage them. And also it allows the unified forwarding plan. So physical switch used in a CAS use a unified forwarding plan and share the synchronized forwarding information in a real time, and inter-device link aggregations link between the physical switch aggregated into a single Eth Trunk interface to interconnect downstream device. So the applications are basically when the port density of a switch cannot meet the access requirements, and the new switch to set up an ISTAT to increase the number of the ports lah. Okay, and also first where you're going to apply the ISTAT, you can going to use it to extend your ports quantity. And also you can extend the bandwidth and implement the redundancy of the backup here. Okay, to increase the uplink bandwidth, a new switch to set up an ISTAT and add a multiple link to a member switch to a Eth Trunk. So this will increase the uplink bandwidth and implement the inter-device backup and inter-device link redundancy and improve the reliability lah. Because you're going to Eth Trunk, add more device which are logically to be a one interface lah. Okay, so on here also you can go into two devices, form a CAS and virtualize into a single logical device. Okay, you have a two switch but under a single. So this will simplify the network, does not require a multiple spanning tree. You don't need a multiple spanning tree, and also a virtual router redundancy protocol, VRRP protocol to do it. So the network configuration is much more simple, and also inter-device link aggregation speed up the network convergence and improve the network reliability. Okay. Then this one is the recommended if you want to apply the ISTAT and also the CAS technology from the Huawei. So under the closed layer, you are going to set up your CAS and use the Eth Trunk to connect the uplink and downlink devices there. So under the aggregation switch, you are going to use the ISTAT. Okay, and then you Eth Trunks your upstream and downstream device and build a more reliable load-free. So under your access level, you also can apply the ISTAT on your access switch, so that you no need to enable the STP and VRRP lah. Okay, protocol router redundancy protocol. So this will going to offer you a high reliability, high uplink bandwidth, and also bandwidth, and also the fast convergence. Okay, so we're going to summarize what we're going to learn under this topic. Basically, we're going to learn about the link aggregations. Okay, we have been looking on two types, manual mode and also the LSCP boot, and how actually you're going to determine the actors, active interface, and active link. Then we also going to see the technology and also the advantages of the CAS and also the iStat lah. So the first quiz, what are the differences between the per package and also the per floor? So just now I mentioned in most of the cases, we more encourage you to using a per floor because under the per package, a package will be a partitions, okay, and then sent through a different data link. So you will have issues whenever you want to assemble the package from a different link. But if per floor, you will have don't have these issues lah. So you will going to make full use of the bandwidth, okay, on the entire. So how does actors be elected in LACP mode? So again, it will based on the system priority. But if let's say you don't have the system priority, it will based on the MAC address. So again, it's under the layer 2. So we will looking on the smaller value have a higher priority. So what is the advantages of the CAS and also the iStat? So actually they are the technology offered by the Huawei to simplify your network management, to improve your network reliability and make full use of your network bandwidth lah. Okay, and also especially they simplify whenever you have a multiple STP or an STP there. Okay, we're looking on the quiz. When the two switches are interconnected using a link aggregations, which of the following condition does not need to be met on what each member port? Okay, so this one, the first thing, the number of the physical interface connected at both ends, it should be the same, alright? The rates, just now we say also it should be the same. The duplex mode, also it should be the same. The physical number of the physical interface connected to the two ends are the same. The physical numbers of the physical interface connected to the both ends. So this one is incorrect. So answer it will be a D. It should be the number of the physical interface, bukan physical numbers of the physical interface. Okay, next we were going to find out which one is the correct for the link aggregations. Link aggregations can prevent the routing routes. No. STP can prevent, but the link aggregations cannot. Link aggregations increase the interconnections bandwidth of the device. Yes, because you have a difference. Example, this one have a 30-20, so you can trunk them to offer a 50 bandwidth. So correct. Link aggregations improve the reliability of the device connections. Also correct. Link aggregation implemented only at the physical layer and irrelevant to the data link. No, it should be under the also because it's represent logically, so it will be under the layer 2 also. So answer B and C is the correct answer. Which of the following types of the internet link aggregator are commonly used? So we have a manual. Okay, we don't have the manual LACP. We have a dynamic LACP and static LACP. So answer it will A, B, C. All Huawei S-series switch support the iStat function. So answer false. No or. The old versions, they actually did not offer the iStat functions. A maximum of the 8 physical ports can be bundled into a one logical port. This one is true. Maximum 8 physical port. CAS iStat simply a network management, improve the network reliability and make full use of the network link bandwidth and use the inter-device Eth Trunk to construct a loop-free physical. So this one also is a true. Package disorder may occur if the packets are loop balanced to a different link based on the packet. So this one correct. If the packets are loop balancing to the same link based on the flow, the package disorder will not occur. Correct. However, a single flow cannot make full use of the bandwidth of this entire Eth Trunk. Also is correct. So answer it will be a true. So that's all for this topic for the link aggregations, iStat and also the CAS.